Problem 26 says the function is one-to-one. Now, I know we talked about parabolas not being one-to-one, but they've restricted the domain. They said, I'm only taking the right-hand side of this parabola. Only when x is positive will I calculate these. And so they've forced it into being one-to-one. Find its inverse. Remember, they had to do that because inverses can only be found when it's one-to-one. So what we do for inverse is we change all our x's to y's and all our y's to x's. We interchange those two. And what's interesting, it ends up making the domain and the range switch positions too. So instead of y, f of x is our y variable, I'm going to put x equals 7 times, now instead of x, I'm going to put y squared. So my y became my x became my y, minus 3. I got the whole thing. And now this would be for y greater than or equal to 0, by the way, because I changed that x to a y as well, even in the domain. So now this is my range. And now I just need to get y by itself so I can put it back in function notation. So I'm going to add the 3. And then divide by 7. And that'll equal y squared, so I just take the square root of both sides to undo the squaring, and the square root does that. So now the question is, usually I do a plus or minus here, but we said y is only positive, so this is going to be just the positive square root. And, you know, we don't usually write the plus, but we're not going to write a negative is the idea. So the actual inverse function is this. I can write f inverse of x equals the square root of x plus 3 over 7. Now I look at my answers. This one has a negative. That's no good because I needed y greater than 0. That's all wrong. This looks pretty good. And that one's upside down. So B is the correct answer. Now, the problem above that, 25, is find the inverse when they give you just 4 points. So we might want to check if it's one-to-one first, but I don't see any repeats in the x's. We have 10, 8, 6, and 4, and I don't see any repeats in the y's, -9, -8, -7, and -6. So it is one-to-one. All we have to do is switch them around. So we're looking for -9, 10. Somewhere here would be -9, no, not -9, 6. We want -9, 10. I don't see any of that. That doesn't have a -9 at all. This has -9, 10, all right. And then -8, 8, yep. -7, 6, yep. -6, 4, yep. And then the domain is the new x's. So -9, 8, 7, and 6. -9, -8, -7, -6. The range is 10, 8, 6, and 4. So C is definitely the right answer. All right, problem 24 is a rational expression, and it's an inequality. This is a lot of stuff from chapter 5. So chapter 5. When we want to do an inequality for a rational, we need to find a lot of the sort of key points. Now, you might say, wouldn't it be great to multiply through by x minus 3? But here's the problem with an inequality. I can't multiply by x because I don't know if it's positive or negative. And if I multiplied by anything with an x in it, I may have to change the sign, but I don't know until I know what x it is. So I have to evaluate this function. I have to, find out information about the function and then see when it's negative. I'm looking for negative or 0. Okay, that's what less than or equal to 0 means, right? So I'm going to kind of sketch out a graphy thing here. I can find the y-intercept by setting x equal to 0, and then I have -6 over 3, which is -2. So I'm intercepting down here at that's where y is 0. When x is 0, y is -2. So I'm good. Now, that's my y-intercept. My x-intercept is going to be the 0 of the numerator. So I'm going to write all that down. Y int is when x equals 0, and so y equaled -6/3, right? And now my x int is y equals 0. So now I have to set x minus 6 equal to 0, so x will equal 6. So at x equals 6, I have a new point here, 6, 0. This one is 0, -2. Now, because it's a rational function, I also have the problem that I cannot allow x plus 3 to equal 0. So I have an asymptote, a vertical asymptote at x plus 3 equals 0. That's my denominator. Don't divide by 0. So if I subtract 3, I get x equals -3. So over here, x equals -3 is my asymptote. So now I have some points here to get a sense of. Now I didn't find any intercepts here, so to connect my dots, I definitely have to go down. I'm not allowed to go up because I didn't find any intercepts here. So to avoid the asymptote, I have to go down. So that has to be that way. And then it crosses over positive here and does something, I'm not sure what, but I don't have another asymptote. So it's just going to keep going and stay positive over here, right? So in this range, my function's positive. From here to here, my function is negative. It's below 0 here. And then I need to find out what's happening over here. So I'm just going to test a point to the left of -3. I'm going to try -10. Because there are no intercepts here, if it's positive, I'm going to live up here positive the whole time. For everything from -infinity all the way to -3 is going to be positive. But if it's negative, it's going to be from -infinity to -3, that whole area is going to be negative. So I'm going to test a point and find out when x is -10, -10 minus 6 over -10 plus 3 is going to equal -16 over 7, right? Oh, no, -7. So negative divided by a negative is positive. So I'm going to be up here. So it's going to do something like this. And yeah, so I've just established it's positive here. Now, go back to the original problem and see I'm looking for negative or 0. That is only between here and here. So I cannot include -3 because it's an asymptote, but it's negative all the way until I get to 6. I'm only looking at x. I'm looking at whether it's below the x-axis, and then what are the x values that make that true, right? It's this part of my number line. And it will not include the asymptote, but it will include the 6. So I'm going to put a box around it. So the right answer is -3 to 6, including only the 6. It would be this one. Now, I'm including it because it says or equal to right here. Okay, less than or equal to. So that makes D wrong because this is the wrong symbol. This one's the wrong numbers altogether, also the wrong numbers altogether. Okay, so hopefully that made a little bit of sense. This is similar to the grid that we used to make where we found the zeros, the x-intercepts, and we found the asymptotes, and then we laid out our line here and set up our x plus 3, x minus, x minus 6, and then our f of x, which was a combination of those, right? And we said, okay, we have -infinity to -3. We have -3 to 6, and then 6 to infinity over here. So we had these 3 regions, -infinity to -3, -3 to 6, and then 6 to infinity. And we said, all right, it's all negative here, which makes this positive. it's etc., right? We did that analysis. So that was very similar to what I did here. I just drew it on the graph instead. So multiple opportunities and paths. 23 is a little bit easier because it's not rational. We have no asymptotes. Also, we know that we're not going to include any of our actual zeros because we want purely negative, only negative, not positive values. So this is set up very well for that table I just discussed. It is actually 0 when k equals 8, when k equals 3, and when k equals -2, right? So if I set k minus 8 equal to 0, I get 8. K minus 3 equal to 0, I get 3. And then k plus 2 equals 0, I get -2. Now I put those along my number line. And in order, I have -2 here. I have then 3, and then 8 is over here. So they're kind of out of order in the given setup, but I need to put them along my x-axis here. Now my regions are from -infinity to -2, right? Or -2 to 3, or 3 to 8, or 8 to infinity. So I'm going to test all of these, k minus 8, k minus 3, k plus 2. This is actually our k-axis, I should have said. And then f of x, which is the whole thing. And that's where I'm going to really look for, am I negative altogether? I need to test points inside these regions. So -infinity, I'm going to check -100. All right, well, that's negative, that's negative, that's negative. All right, 3 negatives makes the whole function negative. Cool, we might have found our first region. But when I get between -2 and 3, that little 0 is in there, so I'm going to test 0. And 0 minus 8 is negative, 0 minus 3 is negative, but 0 plus 2 is now positive. So negative times a negative times a positive is a positive. I want positive. So I'm not going to include this region. This is a winner. This is not, because I wanted negative. Over here, 3 and 8, 5 is in there, so I'll test 5. And I'm just testing 5. It doesn't break up my region. I was testing 0. It doesn't break up my region, so I like to keep that clean. So if I test 5, 5 minus 8 is negative. 5 minus 3, though, is now positive. And 5 plus 2 is positive. So the whole thing becomes negative because only one of these is negative, and they're all multiplied together. Then over here, I have 100. 100 minus 8 is positive. 100 minus 3 is positive. 100 plus 2 is positive. And the whole thing's positive. So these are my two winners, and they can be described as -infinity to -2 and 3 to 8. So I'm going to look for that. -infinity to -2. That's C here, and 3 to 8. Yes, definitely C. Yeah, these don't start at -infinity, so C is the right answer. All right, I'm going to graph this rational function. So let's make a list of things we need. The x-intercept, which is when y equals 0. The y-intercepts, there's only one of these. There might be more of these, which is when x equals 0. I need vertical asymptotes, like problems with my domain, right? This is a domain question. And that'll help me out. And then I might have to test some points to see what's going on. So the y-intercepts when x is 0, that's easiest because then I get 0, 2 times 0 is 0, over 0 plus 0 minus 8. Well, 0 divided by anything is 0. So it turns out my y-intercept is at the origin. So I have the point 0, 0 on my graph, which means that's also an x-intercept, which is interesting. But I need to set y equal to 0. Yeah, that only happens in the numerator, because if I set it equal to 0, the denominator doesn't really matter. So this is where I find my x-intercepts, and it turned out to be also my y-intercept. So 0, 0. Now my vertical asymptotes come from here. My asymptotes come from the denominator. So I have to set x squared plus 2x minus 8 equal to 0 and say I don't want to include that. But my asymptote will actually be that. So it'll be out of my domain, but it'll be a graphable asymptote. So let's solve that. Let's see, -8. I'm going to try factoring. I think this will be doable. -8 means this will be, one will be negative and one will be positive, because when they multiply, I have to get a negative. My leading coefficient is 1, 4, and 2. 4 and 2 sounds good, but I need the 4 to be positive because it's more. It'll end up being positive, and 2 there. I think that'll work. Yeah. So x minus 2 equals 0, or x equals 2 is one vertical asymptote, and x plus 4 equals 0, or x equals -4 is my other vertical asymptote. So I think I'm ready to start sketching. So I have a point on my graph at 0, 0. That kind of covers both of these things. Now my asymptotes are at x equals 2 and x equals -4. Sorry about the throat noise. X equals -4. Now I don't know if this goes up this way or down this way, or it might touch and then bounce back up again. I really need to check these intervals. Where are my points? So what I'm going to do is test, well, what I might do at this point is just graph it on the, I've shown enough work. I might just graph it on the calculator and say, hey, look, there it is. So if I just type in y equals my function, 2x, now the important thing is to hit divide and then open a parenthesis, because if you don't put the denominator in parentheses, you're doing it wrong. So now we have a parenthesis and x squared plus 2x minus 8. Squared plus 2x minus 8 is my denominator. 2x is my numerator. So now I'm ready to graph it. Got my standard window, which is actually going to be great. You can see my asymptote at x equals -4, my asymptote at x equals +2, and I can sort of sketch out that this goes like this, and like this, and like this. Don't touch the asymptote. Okay, and also please make sure that this is approaching horizontal and not looping back down, because that end behavior is important. Going both directions, it's approaching the y equals 0 line. So that's a horizontal asymptote that tells us about our end behavior. So please don't make it loopy. Just make it, try and go as straight as you can without touching asymptotes, or horizontal or vertical. Great. Then that is, I don't know which number that is, but looks like -4 and 2. Nope, this one's facing the wrong direction. My test points are going the wrong way. Also facing the wrong direction. So -4 and 2, looks like D might be my best choice, because this one has +4 and -2. Those are the wrong asymptotes. So D is the correct graph.